Good morning to one and all. Welcome to our webinar titled Design for Environment Towards Sustainability. We request all of you attending the session to mute your microphones except speakers. We will be recording this webinar and this will be shared with all of you after the session. We will send out a survey at the end of this webinar. We request that you provide valuable feedback. In case you have any questions, please use the webinar chat option to post them. We can address your queries by the end of the session or follow up with you later. Today's speakers are Sonia Peter, who is a project lead in product compliance services. She has been with APA for 12 plus years, and myself, Krishna Rao, I have been working as a regulatory compliance engineer. I have been working in this division for more than 4 years. Now a bit about ourselves. APA began in the year 2000 to provide global sourcing services to the automotive components industry. Our core offering is centered around supplier management, procurement, and logistics, and later we expanded into product engineering, compliance, and IT services. Today we are ISO 9001, ISO 27001, and TISAC certified and accredited members of AutoCare. We serve more than 350 customers in the US, EU, and APAC regions. We provide services and ready-to-use software tools that help clients automate compliance processes. Time for a quick poll. Let's take a quick look at the agenda. Each subheading would be explained in detail in the upcoming slides. Why design for environment? Every product has an effect on the environment. DFE offers businesses as a useful technique to reduce these effects in an effort to build a more sustainable environment. Practitioners of DFE have discovered that effective DFE practices improve product quality and cost while decreasing environmental effects, which is just as effective as design for manufacturing practices have shown to do. A product's potential environmental effects can include energy consumption, the depletion of natural resources, liquid discharges, gaseous emissions, and the production of solid trash. Conscious material use, energy efficiency, and waste avoidance can be defined in the early stages of the product development process to reduce or either eliminate such environmental implications. We will discuss about these possible implications in the next slide. Let's talk about these implications, or we could call them as environmental impacts. There may be numerous environmental effects over the course of a product's life cycle. The list that follows explains some of the environmental effects. Global warming. According to scientific data and models, the Earth's temperature is progressively rising as a result of the buildup of greenhouse gases and water vapor in the upper atmosphere. Emissions of carbon dioxide, methane, chlorofluorocarbons, black carbon particles, and nitrogen oxides from industrial processes and products appear to be hastening this effect. Resource depletion. Many of the raw materials used in manufacturing, such as iron ore, gas, oil, and coal, are non-renewable and in short supply. Solid waste. Through their life cycle, products can generate solid waste. Some of this is recycled, but the vast majority is disposed of in incinerators or landfills. Incinerators emit toxic ash and pollute the environment, which goes to landfills again. Landfills may also produce toxic substances, emit methane gas, which is commonly known as CH4, and pollute groundwater. Water pollution. Water pollution is most commonly caused by discharges from industrial processes, which can include heavy metals, fertilizers, solvents, oils, synthetic substances, acids, and suspended solids. Waterborne pollutants have the potential to harm groundwater, drinking water, and fragile ecosystems. Air pollution. Emissions from factories, power plants, incinerators, residential and commercial buildings, as well as motor vehicles are all sources of air pollution. CO2, oxides of nitrogen, sulfur dioxide, ozone, and VOCs are examples of common pollutants. Land degradation. Land degradation refers to the negative environmental effects of raw material extraction and production, such as mining, farming, and forestry. Reduced soil fertility, soil erosion, the salinity of land and water, and deforestation are among the consequences. Biodiversity. The diversity of a plant and animal species is threatened by land clearing for urban development, mining, and also other industrial activities. Ozone depletion. The ozone layer shields the earth from the harmful effects of solar radiation. However, it degrades through reactions with nitric acid produced by the combustion of fossil fuels and chlorine compounds such as CFCs. Now an overview of design for environment. So steps in the product development process such as conscious material use, energy efficiency, and waste avoidance can be specified during the early stages of the development activity to minimize or eliminate environmental impacts. Once the design is finalized, attempts to improve environmental performance typically result in time-consuming design iterations. DFE may include activities at any stage of the product development process and necessitates an interdisciplinary approach in the development of environmentally friendly products, wherein different disciplines such as industrial design, engineering, purchasing, and marketing all collaborate. DFE is based on life cycle thinking. This contributes to the manufacturer's focus on product production and distribution to a closed loop system and connects the product life cycle to the natural life cycle. Moving on to the next slide. So we have sustainable product life cycle. Let's get a brief description on sustainable product life cycle. The first step in the life cycle of a product is the extraction and processing of its raw materials from its natural resources, which is followed by its production, distribution, and use. Finally, when the product's useful life is up, there are several options available to carry out recovery, including component remanufacturing or reuse by material recycling or disposal via incineration and landfill deposit. There are three challenges in creating a sustainable product design. So the first one being eliminating the use of non-renewable resources, and which also includes non-renewable energy sources. The second one being avoiding the disposal of inorganic materials that do not degrade quickly. And the last one, stopping the production of toxic wastes that don't belong in natural life cycles. The 7 steps involved in implementation of DFE process. The effective implementation of design for environment includes activities throughout the product development process. This flow chart that you can see here It depicts the steps of the DFE process. And despite the linear flow of this process, product development teams will most likely repeat some of the steps several times, making DFE a trial and error operation. So the first things first, initializing the DFE agenda. And the step one being establishing the team, drivers, and goals for the DFE agenda. So setting the DFE agenda kicks off the DFE process during the product planning phase. And the three tasks that make up this step are identifying the internal and external drivers of the DFE, establishing the product's environmental goals, and assembling the DFE team. The organization determines a distinct and feasible route towards environmentally friendly product design after creating the DFE agenda. The DFE objectives within the company are the internal drivers. And typical DFE internal drivers include but are not limited to the quality of the product in relation to its environmental impact, cost reduction by using less material and less energy, innovative changes to product design, improvement in occupational health and safety of employees, motivating employees to lessen the negative effects of the company's products on the environment, a moral commitment to protecting the environment and nature among managers and product development, and shifting to a more cleaner lifestyle and increasing the desire for greener products by making them more widely available. The external DFE drivers include environmental regulations, customer preferences, and competitor offerings. And some of the examples would be rigorous practice of product-oriented environmental policies, meeting market demands for sustainable products from end users and well-informed industrial customers, stiff competition from other companies implementing sustainable practices, impact of suppliers on corporate behavior by developing more environmentally friendly products and procedures. Businesses may decide to verify environmental claims made by their suppliers through audits. And now moving on to the environmental goals. So setting these environmental goals for each product development project is a crucial step in the product planning phase. Numerous organizations have developed a plan with long-term environmental objectives. These objectives specify how the company complies with environmental laws and how it lessens the environmental impact of its operations, products, and services. In the table that you can see below, examples of DFE objectives are included and stages are sorted by the product lifecycle. Materials. So when we go by materials, we could use fewer raw materials, choose resources that are accessible and renewable, remove all hazardous substances. We could improve the energy efficiency of the methods used to extract materials, decrease waste and discard, use recycled and salvaged materials more. And for production, cutting back on the processing materials we use could help, indicating which components of the process could be entirely recovered and recycled. And continuing with production, we could remove the hazardous process components, choosing the procedure that we use to use lesser energy, and cutting back on production waste and scrap. Distribution. Deciding on the most energy efficient transportation methods, transport emissions could be reduced. We could stop using hazardous and harmful packaging materials, and we could also start to implement more of reuse and carefully discard packaging materials. Prolonging the product's usable life, facilitating product use under the desired circumstances, facilitating orderly and effective servicing activities, reducing pollutants while lowering energy usage could extend the product life cycle. And when it comes to recovery, assisting in product disassembly so that materials can be separated, permitting component recovery and remanufacturing, encouraging the recycling of materials, decreasing the volume being burnt and deposited in landfills. So another important step in Achieving proper design for environment product would be setting up a DFE team. So DFE typically requires the involvement of a numerous functional experts in the product development project. A DFE team typically includes a DFE leader, an environmental chemistry expert, a manufacturing engineer, and a supply chain or purchasing representative. Obviously, the composition of the DFE team is determined by the organization and the needs of the development, the job, and these could include marketing, outside consultants, suppliers, and also other specialists. Now, I'd like to call upon Sonia to continue with the rest of the DFE implementation process.
Thank you, Krishna. Now, coming to the second step of the DFE process, in the concept development phase, we need to identify the potential environmental impacts of our product over its life cycle. To do so, we need to consider some questions in each stage of the life cycle. In the raw material stage, we have to check out the type and quantity of material to be used. And also, we need to analyze the environmental profile of the selected materials and understand the energy requirements to extract those materials. Likewise, in the production stage, we need to assess what types of production processes will be used and how much the energy consumption would be. During the manufacturing process, we have to look at the types of waste generated and how is it to be managed and disposed of. In the distribution stage, we need to examine how the product is transported from the manufacturer to the customer and what is the carbon footprint of this transportation by considering the means of transport and the kind of packaging to be used. When it comes to the use stage, it is important to study technical as well as aesthetic lifetime of the product. Also, how much maintenance and repairs will be needed. This study helps us in ensuring a greater life cycle of our product. During the recovery stage, we need to inspect what options are available for the disposal or reuse of the product. Is it possible to identify the materials used and sort them properly for recycling? Next slide. After completing the above assessment, we will be able to derive a qualitative analysis chart that helps us in identifying the type and magnitude of each environmental impact resulting from each life cycle stage as shown here. For example, at the material stage, the potential impacts can be reduced biodiversity, land degradation, and natural resource depletion. In production phase, due to waste generation, the main impacts will be air and water pollution. Similarly, during the distribution phase, air pollution will be the main impact considering the In addition, we will also have waste generated due to packaging. While using the product, there will be a loss of material, and at the recovery stage, only a portion of the product undergoes recycling. The remaining part ends up in landfill, causing land degradation and water and air pollution. From the height of each bar, we can get an idea of where to focus our DFE efforts. Also, I would like to highlight here that this qualitative assessment may vary depending on the product that we are making. Like for products such as automobiles and electronic devices, the most significant impacts are found to be in the use stage. However, for other products, for like example clothing and office furniture, the greatest impacts may be in the materials, production and recovery stages. Next slide. Now we come to the next step in the DFE process, which is the selection of DFE guidelines. This is important because selecting the DFE guidelines will allow the product development team to apply them while developing the products. We have segregated here some of the best DFE practices that can be applied at each life cycle stage to reduce the environmental impact of a product. While considering raw materials from the sustainability point of view, we need to use renewable and abundant resources instead of non-renewable materials. We should also use recyclable or recycled materials instead of virgin materials. Also avoid using materials that are toxic or hazardous to human health and the environment. And inclusion of labels would be the best practice for safely handling toxic materials. When it comes to the production stage, we should focus on using energy efficient production methods by minimizing the use of heavy motors and extensive cooling. Also, try to minimize the number of components or go for lightweight materials. During the distribution stage, we can minimize the environmental impact by using environmentally responsible transportation and packaging methods such as minimize long distance transport by maximizing work with local suppliers and markets. Also, we can minimize the amount of packaging material or by making the packaging reusable or recyclable. Next slide. Some of the best practices in the use stage can be followed by reducing standby power and using feedback mechanisms to indicate how much energy or water is being consumed. And to increase the product's durability, consider aesthetics and functionality equally to ensure that the aesthetic life is equal to the technical life. This would help us to decrease the disposal of operational products because of outdated aesthetic design. Also facilitate the repair and upgrading of the developed products and ensure minimal maintenance. Lastly, it would be recovery. In this stage, it is highly directed to ensure a smooth disassembly, separation, and purification process. For that, the joints and fasteners need to be easily accessible and make sure that clear instructions have been given for disposal and recycling. This will enable higher recovery of materials and therefore decrease the need for new raw materials. Next slide. While moving on to the fourth step is applying the selected DFE guidelines to the product design. By assessing the product requirements, we can apply the most relevant DFE guidelines during the initial product design phase itself. More importantly, the DFE guidelines may inspire product development teams to come up with an improvement in the functionality and durability of the product. This will result in the product having a reduced environmental impact by choosing low impact materials such as recycled materials, biodegradable materials, or materials sourced from sustainable sources. Secondly, energy efficient process during both production and use. In addition to that, selecting the minimal waste generation method to reduce the amount of waste generated throughout the life cycle of the product. Next slide. Now let's turn to the next step, that is assessing the environmental impacts of the product over its entire life cycle, that is from raw material extraction to end of life disposal. Life cycle assessment, in short is LCA, quantifies environmental impact over the product life cycle. To perform a life cycle assessment, we need a detailed bill of materials, including sources of energy, component material specifications, suppliers, transportation modes, waste streams, recycling methods, and disposal means. The main steps involved in a LCA analysis is listing out all proposed design options for the product, identify the complete product life cycle, including recycling and disposal, identify all the materials and energy sources used as input and all the outputs and waste stream. Once we have all the above listed information, next step is to quantify environmental impacts based on identified inputs and outputs. And finally, aggregate the quantified impacts into categories for comparison. Next slide. Once we are done with the life cycle assessment, it's important to compare the environmental impacts of the evolving design to the DFE goals established in the planning phase. In case if none of the design meet the goals, we should go for redesign and repeat the assessment until the environmental impacts have been reduced to an acceptable level and the environmental performance fits the DFE goals. We have to remember regular assessment of the materials, energy efficiency, and waste generation, as well as new technologies and alternative approaches, can further reduce the environmental impact of the product. Please understand that the redesign for ongoing improvement of DFE may also continue even after the production process. Next slide. And finally, it is important to study and ensure that the process is effective and the results are meaningful. This has to be done by evaluating the DFE process, like how well the process was executed. Also, what would be the improvement steps that can be taken in the future to make more sustainable products. However, we need to understand that in reality, creating a perfect product from a DFE perspective is a goal that may take years to achieve. Effective DFE requires a product development team that strives for continuous improvement. By reflecting on the DFE process and results, you can ensure that the process is effective and meaningful, and that the results are used to inform future design and development efforts. This can help to create a more sustainable future and contribute to a healthier planet. Next slide. Now moving on to the final point of our agenda, a simplified version of DFE rules. So to draw all that together, Design for Environment provides companies with a practical method to minimize or eliminate the environmental impacts of a product. For that, we need to design products and processes with industrial materials that can be recycled continually with no loss in performance, thereby creating new industrial materials. With natural materials that can be fully returned to the Earth's natural cycles, thereby creating new natural materials. That do not produce unnatural toxic materials that cannot be safely processed by either natural or industrial cycles. And we should use clean, renewable sources of energy rather than fossil fuels. Next, I will hand over to Krishna to conclude this presentation. Thank you.
Thank you, Sonia. Now time for another poll. Thank you for answering the poll. So let's a brief description about our softwares. We offer a variety of turnkey solutions for every type of regulation. So Autogen CM is for conflict minerals, and it is a mineral supply chain audit tool and generates consolidated reports of 3TG usage from conflicted areas. Ecogen is an ESG software that guides organizations to align themselves to global sustainability standards. And IMDS AI is validating IMDS tool for multiple compliances, and this has never been easier. So GreenCheck will automate chemical product compliance processes effectively and generate comprehensive reporting. And the MDS Express, with MDS Express, we can analyze, auto-generate material data sheet tree structures, and submit IMDS data with a single click. The SOC analyst and Triple R uses IMDS PDF data to perform substance analysis and recyclability calculations. So skip submissions are performed with the help of GreenCheck again. And SIBS, which stands for Can It Be Sold, is pretty useful for manufacturers, suppliers, distributors, and resellers who need to know if their products can be sold based on regulations applicable at state and county level, which further gives us visually informative product sales reports. And we have a Q&A session coming up next. So we expect attendees to feel free and let us know if they have any questions related to today's topic, design for environment. So please take your time and let us know if you have any queries. Informative session. If you do have any questions, please send us a mail to the ID compliance@apengineering.com. We will respond to your emails as soon as possible. Looking forward to meeting you all in our next webinar. Goodbye.